his words echoed what industry experts had been saying for years. America's power needs were increasing at an alarming rate. Even the massive Columbia hydro plants weren't enough to meet the future demand. To help combat this, the US and Canadian governments signed an agreement called the Columbia River Treaty. This laid the groundwork for more dams to be built farther upstream in Montana and British Columbia. Once completed, this would add more capacity to the system, while extending the benefits of Columbia hydropower to Canadian residents. But these projects were years away from coming to fruition, and even then, they wouldn't be enough to solve the energy shortage alone. The point of Kennedy's speech was that nuclear power was the wave of the future. If utilities began developing nuclear plants now, they might have a chance at beating the energy crunch in the coming years. On February 2, 1967, Portland General Electric announced their plans to build the first nuclear power plant in Oregon. With a generating capacity of more than 1 million kilowatts, this would be one of the most powerful nuclear plants in the United States. The estimated cost was $130 million, or about $1.2 billion today. PGE had spent the last few years studying potential build sites around Oregon. Soon after announcing the project, they settled on a site along the Columbia River, just a few miles south of Rainier and Longview. This would also put it relatively close to Portland and Vancouver, sitting about 40 miles to the north. Previously, the site had been owned by the Trojan Powder Company, a manufacturer of dynamite and other explosives. PGE's new plant would inherit this former name, becoming known as the Trojan Nuclear Power Plant. To help design and build the plant, PGE hired the Bechtel Corporation. By all accounts, Bechtel seemed well qualified for the project. They were involved with industrial construction projects all around the world, and would eventually build almost half of the nuclear plants in the United States. The Trojan plant's reactor core would contain rods of uranium fuel submerged in water. Here, nuclear fission would take place, creating an enormous amount of heat. The water would be pumped into steam generators, transferring the heat, but not the radiation, to a second system of water. This water would be boiled into steam, which would then be pumped through steam turbines. These turbines would turn electric generators, thus producing electricity. The steam would then pass through a condenser, where it was cooled back down into water. This would be circulated back through the system to be boiled into steam, thus continuing the cycle. The condenser itself would be cooled by water pumped in from the Columbia River. On its trip through the condenser, this water would be warmed by a few degrees before being pumped back into the river. As it turned out, this would become Trojan's first controversy. The water coming from the plant would be completely clean and safe, but even a small rise in temperature could spur the growth of algae and parasites, and could have harmful effects on native salmon. The Oregon government put strict regulations on the river's temperature, so PGE had to revise their design. In 1968, the company announced it would spend another $14 million to build a cooling tower on the site. Under this new setup, water from the Columbia would still be pumped into the condenser, but the warmed water would instead be sent to the cooling tower. A natural draft of air would cool the water through evaporation, and this water vapor would escape through the top of the tower. The cooled water would then be circulated back into the system, requiring almost no water to be pumped back into the river. This revised design was praised by regulators and environmentalists alike. While the Trojan project would be a boon to the Northwest power grid, this was only the beginning. PGE was already drawing up plans for 4 nuclear reactors near Boardman, Oregon, and 2 reactors at Pebble Springs. Not to be outdone, Pacific Power and Light was planning to build 6 nuclear reactors in Roosevelt, Washington. They were also planning 3 nuclear plants in Oregon, near Lebanon, Sutherland, and Bandon. The Eugene Water and Electric Board also had plans to build its own plant near Florence. Back up north, 5 nuclear plants were proposed by the Washington Public Power Supply System. 3 of these would be built alongside the N reactor at Hanford, and the other 2 would be built farther west in Satsop. Likewise, Puget Sound Power and Light was planning to build 2 nuclear reactors near Sedro-Woolley. With so many of these projects in the works, the race to the nuclear age was fully underway. Just as the Northwest had made a name for itself in hydropower, it was now destined to set a national example for nuclear power as well. In the spring of 1970, PGE revealed detailed drawings to illustrate their plans for the Trojan site. While the property would span over 600 acres, the plant itself would only take up a small fraction of this. Most of the site would be developed into a recreational space, with trails, picnic areas, and facilities for boating, fishing, and swimming. By doing this, PGE hoped to show that nuclear power was safe for the environment and for local residents alike. But behind the scenes, Trojan was being developed at a rapid pace with little oversight. Nuclear power plants were regulated on the federal level by the U.S. Atomic Energy Commission. But this agency had come under intense scrutiny over the years, as its standards for nuclear safety were lax and ineffective. The technology was still young, and like many nuclear plants of its time, Trojan was built before the government really knew how to regulate it.
And I think that I was taken, like a lot of Oregonians, by surprise. By that I mean the lay knowledge of nuclear power, I think, was non-existent at that time. What we wanted is someone with definitive authority to accept or deny a license for them to operate. At that time, it was sort of an acquiescence. Oh, well, I guess everything's okay, go right ahead.
Beneath the surface, there were growing concerns among state officials and geologists. One of these was Raymond Corcoran with the Oregon Department of Geology. Corcoran warned that localized fault lines were scattered all throughout the region, yet there hadn't been a comprehensive seismic study of the site. Despite his repeated attempts to raise these concerns, the Department of Geology allowed Trojan to move forward without any objection. Similar concerns were brought up by Len Palmer, a geologist with Portland State University.
We were concerned that they had, and as far as we could tell, never investigated these faults, never looked for them, and never tried to find out whether they were long faults or not. They were making the assumption that the site was good because they already had invested $8 million in site acquisition and investigations without wanting to go in and find out anything that might be a flaw.
Despite these pleas for a more careful inspection of the site, construction progressed through the early 1970s. Among the first structures to be completed was the plant's visitor center. This opened in November of 1973, a couple years before the plant itself was finished. The center would allow school groups and the general public to learn how Trojan was serving their community. This was achieved through state-of-the-art interactive displays and educational films.
All the end uses of electricity are clean, non-polluting. For example, heating for homes, offices, factories. No smoke means not adding to the load of tiny solid particles in the air. No smoke also means no bad smells. The air at Trojan is clean. Nuclear plants have sculptural forms that can be architecturally pleasing. And the sites are sufficiently extensive so that large areas can be set aside for recreation, enjoyment of nature, as at Trojan.
Throughout the early 70s, public support for nuclear power remained high. Part of the reason for this was a national oil crisis that plagued the US from late 1973 to early 1974. As a result, there was a growing national interest in alternative energy sources. Technologies like wind and solar power were not quite ready for commercial use, but they were now given more serious attention. But above all else, nuclear power was seen as the key to reducing America's dependence on foreign oil. In 1975, the Atomic Energy Commission was replaced by a new federal agency, the Nuclear Regulatory Commission. Toward the end of that same year, construction had finished on the Trojan plant, and the NRC officially issued its operating license. 2 days before Christmas of 1975, Trojan supplied power to local homes for the very first time. Testing would continue over the next 5 months, and on May 20th, 1976, Trojan was commissioned for commercial use. PGE's years of work had finally come to fruition. Oregon not only had its first nuclear power plant, but one of the most powerful plants of its kind in the United States. At the time of its completion, Trojan's price tag was $460 million, or around $2.5 billion today. Construction delays, rising labor costs, and historic inflation had more than doubled the original estimate. This immense cost would ultimately be passed on to PGE's customers. But in the years it had taken to construct the plant, the energy crisis had started to change Americans' habits. Utility costs had risen significantly in recent years, and people had learned to save money by using less electricity altogether. Energy conservation was the new name of the game. This mindset shift wouldn't happen overnight, but it was already having a measurable impact. Forecasts of future energy demands were already looking far less drastic than just a few years earlier. Case in point, at the time of Trojan's opening, there was plenty of Columbia hydropower to keep up with demand. As a result, the brand new nuclear plant sat unused for the entire summer of 1976. But even after it resumed operation later in the year, it suffered from frequent mechanical issues and unplanned outages. Meanwhile, over the last few years, Trojan had come under fire from anti-nuclear activists. These activists had tried and failed to stop the plant's construction. One of their biggest concerns was the issue of nuclear waste. The uranium fuel rods used in the fission process needed to be replaced on a regular basis. These would remain dangerously radioactive for thousands of years, yet there were no standards for how to safely dispose of them. This issue had already become painfully obvious at Hanford. The US government had been using Hanford as a dumping ground for the nuclear weapons program, and the results were proving disastrous.
The Hanford Reservation is a nuclear industrial park with many private and public facilities. It is here in a massive underground subway system that the largest amount of high-level waste from the weapons program is stored, 55 million gallons. It is also here that the largest leak of radioactive waste ever occurred in 1973. 100